It's a pleasure to talk back home. I was thinking what to talk about in the meetup because it should be something that's interesting sort of for both of the groups. So let me ask, how many people here are mainly .NET developers? How many people do C#? Good. How many people are functional programmers? So yeah, there's sort of nice mix of both, and I want to show you a little bit of F#, but also in a context where you can use some of the ideas if you're doing .NET programming. And I have two different titles for the talk. One is the one you see. The other one, which proves to be less popular, is doing boring things with F#. But there's a lot of stuff that you have to do when you're doing development. That's not the core part of what you're doing. And over the years, the F# community, I think, came up with some really nice tools that you can use in any other, even if you're doing C#, even if you're using other languages, you can use many of the tools and they will make your life better, hopefully. So that's what I want to talk about. I'll just start with this banner for the F# Software Foundation. This is one fairly recent development in the F# space because F# started as a Microsoft research project a long time ago, but then it was open source since the early days, and it was becoming more popular in other platforms outside of Microsoft world. So there's things like nice support for F# in Xamarin Studio for doing mobile apps. There's various web programming tools. And there's just other companies that do F# that don't rely on Microsoft. And with the foundation, we wanted to bring together all the sort of businesses around F#, but also the open source community who might not be even using anything from Microsoft. People who use F# in Emacs or Vim, on Linux or Mac. And so we started the F# Foundation, which is now it's actually officially registered US nonprofit that sort of has the goal of bringing together everything around F#. And it's also a nice page where you can start if you want to learn more. So F# has been working in an open source way for quite some time. And this is a tweet shortly after the F# compiler, the sort of Microsoft's version of it, started taking pull requests, which was roughly at the same time when the C# compilers were open sourced and started taking pull requests. And you could see that the F# community really is doing a lot of open source stuff, and it's fairly active. So my most popular social network is GitHub, obviously. So a little bit of history. I think in 2010, that's when F# compiler and core libraries were released under the Apache license, and there was sort of an open source version on this URL, which was taking contributions from the open source community, making F# run on Mono, and improving the cross-platform story. And then Microsoft have their own fork of F# where they also have the Visual Studio tooling, which is also now fully open source. So this is the ancient times. There's also a very active F# ecosystem. So if you go to one of these GitHub places, there's a bunch of projects. Many of the core F# projects that pretty much everyone's using are hosted somewhere here. And I think everyone in the F# community really likes doing open source because it's fun, but there's the dark side of it, which is that, and this is not really just open source. I'm talking about it in the open source context because that's what I'm familiar with, but this is the case for any software development. So if you're doing open source, you really should have some tests because someone will want to contribute and you want to make sure that they don't break your code. you also want to be able to quickly release things and build things. And again, this is, I think, super important in open source, because when someone comes and adds a new feature, you can't really say, oh, this is a really nice feature. I'll merge your pull request and release a new version in a half a year when I finally have time to do it, because it takes like a week. So having a good build automation is really important if you want people to contribute. And the one thing that's also important, and nobody likes it, is you have to have a nice documentation. If you're building some open source projects that people should find and be able to use, this is kind of important. And the F# community has a bunch of really nice tools that I'll talk about, which sort of cover these three areas: testing, building, and documentation. And it's also a nice place where you can start with F# if you haven't done it so far, because it's quite easy to get your boss's permission to use F# for writing more tests, because tests aren't really the sort of core production code. And if you have a nice tool that can discover more bugs in your software, everybody will like it. And there's quite a lot of companies that use F# on these various sort of side things, including some companies that do a lot of things in F#, but also .NET, C# companies that really just use F# for one of the things, like for writing tests, or for writing their build scripts. And it's been also a nice place for getting F# into your company. So there's some of the heavy F# users that I know about. They started by writing a couple of tests in F#, and then that's sort of a nice place where you can play with it while not wasting time, because you're doing something useful and you're learning F# as well, and then people sort of become more familiar with it and they feel more comfortable and maybe start using it for something else. So what I'm going to do is I'll start with a little silly example and then show you how you can do some boring things with it. And my silly example, so I'll just create a new copy, AA, that sounds good. So the example will be a pretty simple library for validating passwords. And the point really isn't this library. It's sort of everything that I'll be doing with it. And it could have been written in C#. That's really, it would work the same way because it's something that works with any .NET code. So what this library is doing is that it's defining an interface I requirement. It's also very object-oriented. So if you came to learn about functional programming with F#, this is probably not the best talk because I'm using interfaces and methods. There's really nothing wrong with interfaces, though, because they're just pure functions, especially this one. So I have an interface or a function, and it has a method isSatisfied that takes a password and returns Boolean. And then I have a bunch of basic validators. So I'm creating a length requirement that says create a new implementation of this interface. Here I'm using something that C# people might not know, but it's basically, F# calls it an object expression, where you can implement interface inline in an expression. Java has the same sort of thing. So we're creating a new implementation of this interface where the method tests that the length of the password is more than 8. Then we have a digit requirement where we take a password and we check that there is a digit character in the password. And then I have uppercase requirement where I can say there should be an uppercase character. And then right at the end, I have a power validator, which is a little object, a class, that takes a collection of requirements and it checks that the given password satisfies all the requirements. So it's just a simple .NET library. You could compile it, use it from C#. But the thing I want to start with is to show you the way people work with F#. So I have this project here that I created, which has one FS file, which is the source code. But then I also have this script file, which is where you can write some little piece of code and run it immediately. So what I'm doing here, well, let's start with the usual hello world. I can say hello world. And then when I select it and do Alt-Enter, it opens F# Interactive and prints the result. So I think in C# they sort of did the same thing just about now. If you have the latest Visual Studio with the latest C#, then you'll have very similar thing for C#. In F#, it sort of comes with, it's been there since the early days, so the language works with it very well. So what I can do here is to load my implementation and start writing some code that uses it. So I could say, let's try the length requirement. So now I'm just declaring a variable, and then I can call isSatisfied. So if we say foo, that should be false. If we say foo bar, that's good. The nice thing here is, and this is something that when you're using F#, you'll be doing this all the time, is that when I write the code, write the implementation, I can immediately test it and see if it does what I was expecting. Now, this is not yet a sort of reproducible test that I could run in a test runner. It's just something that I'm doing as I'm writing the code to have a quick sanity check that what I'm doing isn't completely stupid. So if I wanted to do the power validator, let's try that. Create a power validator. This takes a collection of things. So we can give it, let's say, digit and another one, uppercase. So what should be the result of this? False? It is. And if we do this, it should be true. So I guess the first thing here is when you're writing some code in F#, you will usually start with an F# script file where you can just do some things without really worrying about any design. You're just testing ideas. And then when you come up with something that looks like it works, then you'll take the script file, copy it into a project, and start adding the other things. And here I'm at the stage where I wrote the initial version, I created the project, and I have some files in my project with the actual library implementation here, and then a script file with some experiments. So two important things here. When you're doing F#, you can actually write fairly clean object-oriented code, and you can write F# libraries that expose nice C#-friendly public interface. So if you do something in F#, the people who are calling it from C# don't really have to worry that it's in a weird language, because it will just look like a normal .NET code. I also think mixing object-oriented and functional style works pretty well because you can take things like interfaces from the object-oriented style and things like immutability from the functional style. Those two aren't really against each other. And the other thing is, what I was doing here with the F# script file, you can actually use it to call C# libraries as well. So rather than writing hash load with the source code, you can use #r and give it a DLL, .NET DLL. It will just load the DLL, and you can call it and use it. So what I did right now is I wrote some experiments in my F# script file, and now I'm happy with my library, and I want to actually put it on GitHub, for example. And I want to take this script that I wrote and turn it into unit tests. So I don't think there's many people in the F# world who do the strict test-driven development where they write tests first. I think many people sort of write the script first with both the implementation and some experiments and then split it. So what I'm going to do is I'll take this and turn it into tests. How many people are using something like NUnit or XUnit? So I'll be using NUnit. But one thing I want to show you, and this is sort of some of the tools that come from the F# ecosystem. I want to show you the Packet dependency manager. And this is actually something that can be useful even if you're using C#. It is written in F#, but it's just a executable. So what Packet is doing is that it's trying to make referencing of libraries from NuGet a bit easier and a bit less painful. So just one of the things that always annoys me with NuGet is that when you reference a library, it will put it in a folder that has the version number in there, and it will put the version number in all your project files. And I don't know how to do it. When you upgrade to a new version of the library, you either have to do some magic in Visual Studio and click on things until it works, or you can just edit the project file in Notepad. That's usually what I end up doing. And then when you upgrade all your dependencies and someone else does something else with your project, then you'll have lots of merge conflicts in your projects, because every single time you touch something in NuGet, it changes your project files. So that's one thing that Packet doesn't do. It will try to do as few changes in your project files as it can. The other thing it does is that it correctly handles transitive references. So I think in NuGet, when you reference a package that has some transitive dependencies, it will add all the transitive dependencies. But when you update to a new version that has more dependencies, it will not add them, and it will not work. So Packet is just trying to make working with dependencies a bit simpler. And I guess it comes from the F# community, because there's a lot of projects that have a lot of dependencies. So there is even a Visual Studio plugin for it. But what I'm going to do is that I'll just copy over two files. One file is this Packet bootstrapper. And the idea is that this is like 20 kilobytes or something. So you can just put it in your repository, have it there, and when you run it, it will download the latest version of the tool itself. So you can check it into your repository and make sure that you'll be always able to restore your packages. The other file that I added, and I'll just add it here, Packet.dependencies. This is where I have to specify what are my sort of top-level dependencies. So here I'm using two F# testing libraries, FsCheck and FsUnit. And FsUnit actually is just a thin layer, thin wrapper over NUnit. And when I run Puppet and say install, what it will do is that it will find the latest versions of the packages. It will resolve the potential sort of version conflicts if there's some requirements. And then it will produce another file called packet.log. And this is where you can see what are the transitive dependencies, so you can see what are the transitive dependencies, and you can see that FsUnit relies on NUnit. And it also is the file that stores the version numbers of everything. So the typical workflow is that you'll create this file and then check it into your repository together with the bootstrapper. And then you have a guarantee that everyone who gets your repo will be able to build it because they'll get the same versions of everything. All right, any questions so far? So this is the first bit, and now we've got some dependencies, and I can add my test project. And I'm going to do a test project in F#, password validator.tests. There's my tests. And in here, I'll have to do two things. The first thing is I actually need to add app-config. And the whole reason why I'm doing this is that all the F# libraries have this dependency on F# core. And this is just specifying that all the old versions should be mapped to a newer version. So it's just a boring thing you have to do. The more interesting thing is if I want to reference my unit testing libraries in here, I'll have to add bucket.references, which is pretty much the same thing as the packages.config file that NuGet is doing, except that it's not XML. We're not in Java world, right? So I'll just say these two lines, save everything, and this I did run already. Run install again, and it adds all the references, and now I have them right here. All right, so that's all I needed, and what I can do now is to take the scripts I wrote interactively when sort of building the first version and turn them into proper unit tests. So if I go back to my script, I might want to turn this into a first unit test. I don't need this. And open is the F# version of using. So this is pretty simple. Let's call this simple tests. This will be my test. And I need reference to my actual project. And I also need to turn this into actual assertion. So should I put expected or the actual first? Which one's first? Who knows? Expected first. Thank you. Maybe there's like is true. Oh, there's is true. No, this should be false, right? We'll see. We'll see when we run the tests. Let's see if it actually just does anything. Oh, I need to open my other namespace. Are we getting anywhere? I called the test X because I couldn't come up with a better name. So when you're writing unit tests, who likes to use the Pascal case notation for their longer names? Yeah? Who likes underscores? Oh, there's one more snake case. This was snake. Any other notations? Combination of both.
Like, yeah, because underscore can, like, the French is saying, like, what's it tested, and behind the underscore is, like, different cases of
yeah.
Plain sentences.
Plain sentences, exactly. That's what I do. So in F#, you can put double backticks around things, and it will make anything a valid identifier. So I can say length
Once upon a time also.
Sorry? You can, yeah, if you want to put a whole story, you can.
It is maybe quite a silly question. Can I escape the backtick?
Well, I think you can put one there. How do you do two backticks? I don't know. Let's see what happened. No, I don't think you can. If you want to have double backticks in your test names, then you'll have to use a better language. And so this is something that when I first sort of used it, I felt like, wow, this is really weird. Why would you call method like this? But the thing with the test methods is that you never really call them directly. The only place where you see the name, and I've learned a new trick, which I'll have to show you, is here. Go away. How do I get rid of it? So you only really see the name of the method in the test runner, and there it makes complete sense to see a nice readable sentence. The other bit is, so why exactly do I have to create a class just to have my tests there? And it turns out you don't have to, because in F# when you can create classes, but you can also just create functions using let. And when you put functions, so you can't put functions in a namespace because they have to be in something. You can use F# module. And when you have functions in a module, it gets compiled as class with static members. And so it still shows nicely in the test runners. So you don't need a class if you don't need a class. The other, and this is already a bit nicer. There's one more thing that you can do. So one of the dependencies that I added is FsUnit, which is, I guess on the website it says it's F# unit testing framework, but really it's like a 40 lines wrapper over any unit that makes it a bit easier to write these assertions. So rather than saying assert is false, you can say should equal false. And it becomes a bit more readable. There's a bunch of other things, like you can say foo. I think you can say should contain oo. There's a bunch of other things that you might want to express in your tests. So let me just add the other one, and then I'll do one more thing. So the other one was the power validator. And I think this pattern of first doing things in a script file to make sure that what we are doing is roughly right, and then taking it and turning it into reproducible unit tests. That's something that just makes it sort of easier to get the thing right in the first place and then keep it right as you go. And this one was false. True. One other thing that I sometimes do, and I think it's sort of useful, there's a, well, you can run the F# unit tests with all the other standard tools. So if you're using ReSharper or other things, they will be able to find and run F# tests. But one thing that I find nice for debugging and testing is that you can also still set up your F# interactive and run your tests line by line to see where something goes wrong. So the way to do it is that I can actually just, I have to do a little trick here where I can use #if interactive to say this piece of code should run only when I'm running things in F# interactive, and hide all the dependencies, all the references there. So if I do it, if I run this, F# interactive will actually see everything there, and I can step through my tests and see what's happening. So if I wanted to show you the other things like foo contain ff, this will fail. If I change it to oo, then it works. So it's just another thing you can do to make running tests sort of easier and faster when you're writing them. Yeah.
What is the difference between .fs and .fsx?
Yeah. So the difference between .fs and .fsx, .fs is basically compiled file that you can include in your project, compile to get a DLL. .fsx is a sort of standalone script file where generally if you have .fs, you need to have some project file. And fs is part of the project file that specifies your references, other files, and so on. FSX is just a standalone script file where you can use the #r, #load to reference other things. And I think generally you would use fs when you're building any library, and FSX when you have like script you run by hand. And I did put #r in fs here, but that's just because it's hidden. If I put it in there as a normal line, it wouldn't actually work. So here I'm slightly cheating. All right, so now we have some tests. And I have a few more things related to testing. So I'll just show you one, which I think is really nice. And that's the FsCheck project. But before getting to that, so why would you, if you're doing some C# applications, why would you use F# for your tests? Well, there's one very good reason, which is just because you write the tests in another language, that sort of decreases the chance that you'll do the same mistake twice. So if you write the test in some other language, you might write it, you will not sort of just copy the code you wrote in the actual implementation and have the same bug in two places. So that's one nice thing. Also, it makes writing the tests a bit more nicer because you just don't have to put things in a class. You can use nicer names and so on. another feature that's actually really useful is that F# has something that's called structural equality on collections. So this will be a bit silly example, but it will do. I can create a collection with results. So this is a list containing false and true. And then when I say assert are equal and create a new list with false and true and compare it with results, it says okay. It actually works even when you just compare them using equals. So this is true. And that's something that if you want to check that some collection equals to another collection, you don't have to use some specific method to check it because they happen to be collections. You can just compare them. And if you were using something like the .NET generic list, the way that the equality works for lists is that they just compare the references, and if they're different instances, they're not equal. But that's not the case for F# collections. So when you want to check something, check that some result you got, which happens to be a collection, equals something that you expect, you can actually in F# just test equality on the collections.
Could you also show the error that we get from the result if it doesn't equal?
So if it doesn't equal, if we do, so here, yeah, here I would just get false, but.
So I will have to check it manually again as well.
Yeah, I guess if you, well, let's see what happens. Yeah, you don't get the nice error. So in this case, it doesn't find the sort of element where they differed, which I guess is probably a reason why I like to have it set up so that I can just load everything in F# Interactive and then run this, and see it there. So that's how I would debug it. You can still use if the unit testing framework has a nice method for checking collections, you can do it. There's also a library for checking things in F# called unquote, which I think would do it, but I don't have a sample. So I can maybe find it later. But I think unquote would give you a nicer error message. So the other tool that I want to show you is called FsCheck. And how many people have heard of property-based testing? Very good. How many people use it in practice for something? What do you use? Anyone? FsCheck? Something else? Someone? Sorry? Good. Anybody else? FsCheck. It's sort of a fairly. It's a fairly. I don't know. It's not that brand new, but it's sort of an idea that appeared in functional languages. I think it either came first in Haskell or, yeah, probably from Haskell, where in Haskell, when you're testing things, you'll often specify some laws. So, like when you're writing plus operation in Haskell, plus is associative, which means that A plus B plus C is the same thing as A plus B plus C. And this is a property of the plus operator, and it doesn't really. You could test that 1 plus 2 plus 3 is the same thing as 1 plus 2 plus 3, but that's not testing very much. if you have something that's like this property, then it should hold for really any input. And property-based testing is the idea that we should find these nice properties about our code, and then we can write tests that checks something for any input. And what the libraries are doing is that they will check the property for some randomly generated inputs. Now, they will not be completely random. They're sort of cleverly generated to cover all the usual corner cases. But that's the general idea. So what I could do here, and I'll just start in a script file and then turn it into a proper test. I'll have to open FsCheck, which I already referenced. So the usual example that pretty much everybody uses to show this is if I have a list and I reverse the list and then I reverse it again, then it should be the same list. And what do I need? I need to say this is a list. So I have a list of numbers, and I need some parentheses around here. And it runs, and it says passed 100 tests. If I cheat and actually print the lists that it gives me, then you'll see what is happening behind the scenes. It's generating all these ugly lists, and then it gives them to my function, and in the function I take the list, reverse it twice, and check that it's the same list. So does anybody have an idea why this wouldn't work?
Sorry.
No. A question?
It should hold for any list.
Well,
Yeah.
that's a good. Should it hold for any list? People always say that it should. But should it?
What I meant is list of
Any type, yeah. No, there's unfortunately no nice way to say like any list.
If you have that like the lowest integer, like minus the lowest. No.
We are never, so in the function we are not actually like doing anything with the numbers, so it would work even with like min int. So what we could do, yeah, if you want to say like does it work for strings? Works for strings. Does it work for floats? You can't nicely say just like test it for any values. But now something interesting happened. So this is the case where we actually failed. Let me clean this up so that you can see it. If we run it for floats, so it worked for integers, it worked for strings, but when I run it for floats, it says falsifiable after 8 tests. 7 shrinks, then it gives me the random number generator, and then in the end here it says none. Because if you have a list, none doesn't equal none. So list of none doesn't equal list of none, and it doesn't hold for this one. So what it's doing is that it's sort of trying to find all the subtle inputs that can break your things. And it first finds fairly ugly one. So this is the original. That's like a really big number, 0, 2 normal numbers, none, some more normal numbers. And then it does shrinking, where for every input, it has like a function specified that says, how can I make this input simpler? So it generates this ugly list, and then it tries, does it still fail if I remove the first element? Yes, it does. And through this process, it comes with the simplest repro, which is just a none. So could we use it for something in our library? Well, I guess we could validate the length requirement. So the length requirement says we take a password and is satisfied S should be the same as length greater than or equal 8. And just for the reference, we can add that later. So I guess I need to learn how to write brackets. Good. I should definitely switch to closure. My keyboard is still good, so I could do that. Who thinks this will work? Any yes votes? No votes?
No.
Null. Null? Is that an answer or a possible problem? It is a possible problem, yeah. So this doesn't work for null. And just because we're doing this, like null is probably the most annoying corner case that you can get. And when I write tests, I never just try put null everywhere because who would put null everywhere? That's why people like me have to use FsCheck, because FsCheck will just do it for you. So what FsCheck is doing is that it's generating, and you could see it with the floats. Like it gives you a min float, the largest float. It gives you plus infinity, minus infinity, none. It gives you all the possible ugly inputs. So what can we do here? We could either we should probably check what our isSatisfied is doing, because this isn't actually going to work for nulls. So here we should probably fix our code so that it handles the nulls correctly. You can also specify something that they call implications, where I can say the test should only pass if S isn't null. So if I do it now, it will skip all the nulls, and then it works for all the non-null inputs. And I was running this in F# Interactive, but because we are in a test file and we are trying to do a proper software, we can turn it into a test and say, and quick just prints the output. If we want the test to fail, then I'll have to rename it to throw on failure, which will just throw an exception if something goes wrong. All right, so this is the testing part, and let's see if it worked. Ha ha ha, it didn't, because I changed something. Oh yeah, I was messing things up. Now this will work. So FsCheck is really nice if you, in a number of cases, it's really nice if you have multiple different implementations of something. So that's the test oracle case. For example, if you have like a slow prototype implementation and more optimized one, then you can check that the efficient one does the same thing as the slow one. And this is actually something that I have used in practice when I was working on a time series analysis library, where we had like a slow way to do a moving averages, where you would just create all the windows and then average every single window. And we had a fast version which would keep the value that's going out and keep the value that's coming in. And it was so much faster. and then we added FsCheck tests, and it behaved differently for nuns, as one would expect. So that's one really good use case. The other is when you're writing something that has some mathematical logic behind it, because then you can often find some algebraic properties. And that was more on the testing side of things, which is, or I talked about Packet, which is the package management based on NuGet that sort of comes from the F# community, resolves some of the NuGet issues. I talked about the testing bit, and I just want to quickly show you one more project that's bringing sort of everything together. And if you have a look at some of the F# libraries, many of them will follow the same pattern where they have documentation that looks something like this. And so this is a library with type providers for accessing data. And it has some introduction page here. So when people think about documentation, they'll often think about the XML comments that you can put in your C# project, which is all right for some purposes, but what's much more important is to have nice tutorials. So what we have here, and many F# projects have it, is that there's a couple of tutorials like this one that show you how to use the JSON type provider for working with JSON data. And so on. And as a developer, I really don't feel like opening Word and writing the documentation in Word. So the way this works is that this documentation is actually generated from an F# script file. And if I have a look at this on GitHub, there's docs. Where would it be? Content, maybe? Tutorials? Nope. So this is this page where what's happening is that I have some comments in my file which contain Markdown. So this is just a Markdown comment with some headings. And then there's some actual source code which references the library. And then it says more text. And this is the first sample. So there's simple.h, simple.name. That gets turned into this code block. So when you're writing your documentation, you can really just write source code with more comments in the middle that actually describe what's happening. And this is something that in the F# space actually helped many libraries add some at least basic documentation that tells how do you actually use it. There's a few nice things that we can do because it's set up in this way. One thing that the tool is actually doing is that it runs the F# compiler on the code when it generates documentation, and it generates tooltips with the type information. So when you're reading F# code, it's kind of useful to know the types of things because F# is statically typed. And here you can see that this property has type string. This property has type int. This will be int list, and so on. This is an array of some objects. So how does this work? There's actually, and this is something that you can look at if you're doing .NET stuff. It works for C# projects as well. It's a template on GitHub called Project Scaffold, which is basically it's basically a GitHub repo that has a bunch of files in it. I can copy it over here. And it comes with a build script. And when you run the build script for the first time, it asks you for some basic information about your project. So it first uses Packet to download some dependencies. And it depends on a bunch of things. But then, very shortly, it will surely ask us for things. So the repo is sort of set up so that you can easily create a project like all the other projects. And it asks you for things like project name. It asks you for things that are needed for building a NuGet package. So I'm not going to be releasing this, so I'll just put some rubbish there. Validates passwords. Author me. Tags. Stuff. It can also, when you have the project hosted as an open source project on GitHub, it can generate cross links to it. But I'm not going to do it. And this initial build script just renames everything in the folder and generates like a basic template. So I'm going to skip the next bit, which is normally when I use it, I just copy over all the files that I wrote somewhere else. And instead of doing that, I'm going to open a solution where I did it already. So we'll have the same password validator here. So here's my password validator. That's what I was doing before. Here are the tests that we wrote. And the scaffolding adds a bunch of other things. So it adds a README file and release notes. It adds the docs folder. And it adds a build script. And it's nice if you're building C# or F# open source projects, then you can just use it as it is and use it for putting things on GitHub with a nice documentation. But it's also just a nice example of how you can use some of the other tools. And one way to use it is to have a look at it and see if there is there something interesting that we could just copy over from that settings and use it on our projects. So it has a good example of using fake, which is another, fake stands for F# make files. So it's a tool for doing build scripts, and I'll show you the build script here. It uses F# formatting for building the documentation, and you can build the documentation using these tutorial files, but it can also extract the XML comments, and it's using Packet, which I talked about already, for dependency management. So the last bit I want to do before we wrap up is to show you a couple of things from the build script. So if I go to my command line, this is the other one. The project is actually cross-platform, so it generates like build.sh for Mac and Linux, and build.cmd for Windows. And when I run the build, it does quite a lot of things. And this is the last build automation thing that I think is worth looking at. So what it even prints you what targets it's going to go through. It starts by cleaning all the previous outputs. And you can see it here. So in the build script, this one starts with the sort of declaration of all the variables that we that we set when I was running the command line. And this is really just an F# script file. So you can write any code you want there. It's just an F# code. And then it has a bunch of these targets that specify one step of the build. So there's a step to generate assembly info files, which looks for all CS and FsProj files and even VB. And then it generates assembly info with the data. It's also getting the version number right here. This is coming from somewhere else. Oh, there it is, load release notes. So one thing that we did is that many of the projects have release notes, and the best way to make sure that people update their release notes when they build a new version is to make sure that their build doesn't work if they don't do it. So the way this works is that it actually reads the version number from the release notes and checks that that version hasn't been released already. So you can put release notes in your project and make sure that when you're releasing a new version, give it a number. So that's what's happened here, assembly info. Then for building things, it actually doesn't make sense to replace MS-build. So the way this works is that you can just invoke. This is probably the easiest bit. We just say, find the solution file, run MS-build on it. So you can just use MS-build to run the build. The next step is running tests, where we say, find all the test assemblies and run NUnit on them with some parameters. We'll save the results, give some timeout. You can also build a NuGet package, and in here, that's another part of the Puppet tool that I didn't really show you. But Puppet, if you just give it a template file with some basic information, it can build a NuGet package for you in 5 lines and push it to nuget.org. This would definitely fit on 1 line. And so on. So we do the build. Here, this bit is running the tests. So you can see output from the individual tests and from FsCheck, where it generates some random inputs. And then the last bit here is generating the documentation. So once we do it, there's, if I clean this up, I can actually run it from here as well. So if I go to tutorial and change something here, password validator tutorial, I'll add some exclamation marks. And call build documentation. This is the bit that was generating the documentation from my script file. Yep. And if I was still online, then you could see it with nice. If I was still online, you would see it with nice styles and CSS style sheets. But because my phone decided to do something, there it is. It's there with nice styles with the exclamation marks that I just added. So that's this part of the build. And there's actually one last thing, which I didn't run because I didn't set it up. But you can even make the build script push the documentation to the GH pages branch on GitHub. So I think this is a nice example if you have some complicated build process and you want to automate various parts of it. Fake is pretty well documented, so it has a nice documentation with all the different things it can do. and the project scaffold is a nice example of putting a lot of things together. And as a bonus, some of the F# projects, I think F# data that I was showing actually does this. What they're doing is that when they generate the documentation, not only they generate the tooltips, but they also check that there's no compilation error in your documentation. So when you release a new version, when you try to release a new version, or when someone sends you a pull request and changes the public API, and doesn't update the relevant bits in the documentation, your build and your continuous integration will actually fail. So to summarize, I think it's fun to use F# even for the boring stuff. And it's also a nice way to actually start playing with it if you're in a .NET environment, because you can use things like Packet. That's actually just written in F#. You don't need to write any F# code. But it makes your NuGet dependencies a bit easier to manage. You can use things like Fake for writing build scripts that are not encoded in XML. Build scripts where when you want to read a file with release notes, you can just write a few lines of code to do it. And Fake can do like crazy amount of things, from building various deployment packages, pushing them to all sorts of things, reporting errors in various ways. It has a very active community as well. So there's things that people contributed to Fake that nobody even knows what they are because they're only used in, I don't know, in Japan maybe. On the testing side, so I think just using F# is quite nice because you have a few nice features in the syntax that make it easier. You can use FsUnit for writing more readable assertions. You can use FsCheck if you're interested in property-based testing. There's a bunch of other interesting projects in the testing space related to F# as well. And finally, I just showed you the project scaffold, which is a nice example of like putting all the things together and seeing what you can do with it. So I think that's all. I'll have some time for questions, and then we can head over to the pub. Thanks. Questions can be in Czech as well.
So what wouldn't you do in F#?
So the question is, what wouldn't I do in F#? Well, you're asking the wrong person.
What do you think is better to it?
So what are the things that I wouldn't do in F#? I think F# works really well when you have something that's sort of fairly isolated. So I think it's really nice for the sort of auxiliary stuff, which is what I was doing in the talk. I think it's really nice for writing like core calculations or core logic or core domain processing. I probably wouldn't use it if I was trying to do some fairly sort of standard web application or fairly standard UI application. Not because I would think that F# is worse for that, but because there's just a lot of existing good libraries for other things. And it's pretty much the places where F# doesn't have nice libraries. So there's nice library for doing sort of lightweight REST APIs with F# called Suave, but there's no sort of complex UI framework for F#. And that's one place where I probably wouldn't use it, especially if I was in a larger team that has people who can do it in C#, just fine. Yeah? You can start. You were first.
Okay.
Yeah. You.
I was told that a really big part of Bing is done in F#. Do you know why they use it or to what purpose?
So I'm not sure what exactly they're doing. I did talk with some people in the Bing team in Microsoft, and they were using F# for the sort of data analytics they do around all the data they record when you use it. They also, I'm not sure if this is still used, but Microsoft had some time ago like an internal competition for better predicting what ad to show. So when you go to Bing, they can show you an ad, and they can pick one where the person who pays for the ad gives you more money, or they can pick one where they think you're more likely to click on it. So there's this sort of trade-off: do we show more expensive ad, or do we show ad that we think people will click on? And the team that won the competition internally was using F# for it. But to be fair, they were also the only team that actually produced something that worked. So I think after the competition ended, they give the other teams like 2 more weeks to actually fix their stuff so that they can run it. And then they fixed it, and it wasn't producing good results. So that bit is sort of machine learning and data science. All right, there was a question from there.
So you are using a lot of like command line tools and tools outside of Visual Studio. Does that mean that the Visual Studio experience is just catching up, or that it's purposefully built in a way that gives you sort of a flexibility?
So I was using a lot of command line tools. I think that's probably just me, because there's a lot of like F# doesn't have the same sort of Visual Studio tooling that C# has, but for example, for Packet, I was doing it by hand, but there is actually now a Visual Studio plugin which works pretty well. I just used Packet before it was cool, so I'm used to just doing things in the command line. For the build scripts, so I guess the build scripts are generally sort of the idea is you run it from a command line, or it runs on your continuous integration server. That's the one bit where I think you still need the command line. But for all the other sort of package management, that's already there. I did also have one plugin for F# installed called Visual F# Power Tools, which adds a bunch of basic like rename refactoring and other things. So if you're using F# and you like to have nice Visual Studio experience, you can install Visual F# Power Tools, and they're adding. I think it's like 1.5-year-old project maybe, and they already implemented a lot of nice features from things like semantic highlighting, renames, various navigation tools and stuff. Yeah.
Are you still involved with developing the language itself?
Am I still involved with developing the language? Well, so I guess I am, because I go to the pub with the right people. I haven't really done much work on the sort of compiler itself, even though so a lot of the new things that are in the latest version of F# are sort of smaller changes that come from the community via the open source channels. And I haven't really been contributing much to that part because I was busy with the other open source projects that I'm contributing to. The language itself, so I don't think there's sort of any like plans to make another huge revolutionary change. But that's probably because the language itself is already quite good. the other really nice thing with F# is that you actually have quite a lot of flexibility. So things that in C# world would require changing the language, in F# can actually be done just as a library. Am I still online? So one thing that, that's the best one. One thing that they're, I think, talking about in C#, now that there's async and iterators, is to have something like a combination of the two, where you could write asynchronous method that does some stuff, talks to the internet without blocking, but produces a like sequence of values. So something like an asynchronous sequence. And in F#, in C# they have to change the language, and like it will take them 10 years. In C#, there's some nice example. You can actually just write this as a library. So there is a F# library for doing asynchronous sequences, where you can say asynchronously sleep and then produce a value. And one even cooler project that's recently appeared is Embrace, where they don't have any code sample. Well, this one is boring. They don't have any exciting code sample.
You mean yours?
Sorry?
You mean yours?
I haven't actually done anything on this. They're using the documentation tools. Hello world. That will do. So this is again using this computation expressions syntax for building like a block that has a special meaning, except that here you can wrap code in cloud curly brackets, and what it means is that it will sort of be able to serialize the code and run it on some other machine. So what this library is doing is that it lets you write code in F# in a script file, and then just say cluster.run, where cluster is some sort of connection to a computational cluster, and it will distribute the work across the cluster. So I think there's a lot that there's sort of much more that can be done in F# just by building more libraries.
But is there still a hope for putting things like, I don't know, higher candidate types or lists or type classes or anything like that?
I think that's the topic for a discussion in the pub. But no, there's definitely sort of language additions that can go in that direction, and add some of the good things that you get from type classes. So F# has a thing called static member constraints, which is kind of like that.
You have to inline stuff.
Yeah, and so like changing the compiler so that you wouldn't have to inline it, that's one thing that can definitely happen, I think. But I wouldn't sort of, yeah, that's the pub discussion. Like I think there has to be some sort of limit where if you edit a lot of stuff from other languages, you would just end up with something that's. I didn't say that. Yeah, where you need. We were just talking about this model in Scala where they want to have like you basically have to have a. Well, I think the official idea is that you have like language API levels, and only if you're Scala master, you'll be allowed to use some of the fancy things. But that's a pub discussion, definitely. All right, yes?
Yes, maybe another one pub-related question. It seems that F# is, let's say, pragmatic language, because you can also, it is functional,
Yeah.
but you can create classes, you have mutable variables there. So it's covering all of the .NET whatever stuff.
Yeah.
What do you think about aspects?
So I have never actually used aspects. So I don't really know much about it. Yeah, it's a higher order function that
Well,
has a different syntax. I can see a value of doing something like this if it lets you just remove some boilerplate. Like, there's definitely pure functional ways of dealing with it. Whether the pure functional is better than the non-pure functional, I don't have enough experience to say. I definitely think that the functional ways of solving the problem would be much more easier to do in F# than in, say, C#. Yeah, but
Do they steal some things from F# to C#?
have you seen the recent C# language plans? So the question was, do they still steal things from F# to C#? I think they have plans to add pattern matching to C#, and basically record types, and they also say record types when they mean discriminated unions. So yeah, they still do that. All right, I think we'll have to keep all the other questions for the pub. So thanks again for coming.